Hello, welcome. I am Kita Babu Singh, welcoming you all again to this session. In previous session, we discussed multiplexing and time division multiplexing. In today's session, we discuss on types of error, multiple bit error and burst error. Let's know what is error detection and correction. As we all know, data are transmitted in the network. When data are transmitted over network, we do not know what happened to data. Once the data left the node, the data can be corrupted during transmission, called as a transmission error. For reliable communication, error must be detected and corrected. Error detection and correction are implemented either at the end, either at the data link layer or transport layer of the OSI model. So, network must be able to transfer data from one device to another with acceptable accuracy. For most applications, a system must guarantee that the data received are identical to the data transmitted. Anytime data are transmitted from one node to the next, they can become corrupted in passage. Many factors can after one or more bits of passage of a message. Some applications require mechanism for detecting and correcting errors. As we know, data can be corrupted during transmission. Some application requires that errors be detected and corrected. Types of error. Basically, there are two types of error. One is bit error and second one is the burst error. Whenever bit flow from one point to another, they are subjected to unpredictable changes because of interference. The interference can change the shape of the signal. In a single bit error, a 0 is changed to 1 or 1 to 0. So this is nothing but a bit error. In burst error, multi-bits are changed. So this happens in bit burst error. A data unit transferred in a network may be byte, character, or packet. Let's repeat once again. Basically, we have two types of errors. One is bit error and another one is burst error. So as we know, whenever bits from one point to another, they are subjected to unpredictable changes because of interference. The interference can change the shape of the signal. In bit error, a single bit error is 0 changed to 1 or 1 changed to 0. In burst error, multiple bits are changed. So let's start a single bit error. Suppose that during transmission a single bit error occurs, that is single 0 is turned into a 1 or a 1 is turned to a 0. In this slide we have the picture. Suppose we wanted to reliable transmit the result of single coin flip, that is heads. We here in this slide, in this picture we are saying heads, that is 0 and tails 1. A one person who took the heads and the second person, that is who took the tails. The one person who took the heads is nothing but 0 and tails is nothing but the 1. So when we are transmitting data, that is we are saying heads, but at the receiver end it corrupted to 1. When we send the message 0, it corrupted and changed to 1. That is nothing but single bit error. In a single bit error, only one bit in the data unit has changed. As shown in the slide, we have the uh, two boxes in which one is the sender and the second one is the receiver. In sender, we are sent 0 0 0 0 0 0 1 0, and in receiver it receives 0 0 0 0 1 0 1 0. So in this here the 0 changed to 1. It is nothing but a single bit error. The 0 is changed to 1. Single bit errors are least likely type of errors in serial data transmission. To understand why, imagine data sent at 1 megabit per second. This means that each bit loads only 1 divided by 10 lakhs or 1 microsecond. For a single bit error to occur, the noise must have a duration of only 1 microsecond, which is very rare. Noise normally lasts much longer than this. Now let's know burst error. A burst error means that two or more bits in the data unit have changed. In the slide, let us see. Here we have, in this particular slide, we have the example of burst error. The burst error length is 5. One is the message and a receiver. That is message, which is nothing but the sender, and the receiver, which receives the message, that is data. The message is 0 0 0 0 0 0 0 0 0 0 0, and of 0, the 5 length of the data, 5 zeros, is nothing but the burst 5 length. Next, in the receiver side, we have the receiver date, that is 0 0 0 0 0 0 1 0 0 0 1. So this is the burst error length, where the 0 in the sender or in the message is changed to 1, and again the 0 is changed to 1. This 1 1 is nothing but corrupted bits in the burst error. Let us understand by taking the length of 8 bits. At the sender side, we here one is the sender. As shown in this particular slide, we have the sender and a received message, in which the sender sends the data, that is 0 1 0 0 0 1 0 0 0 1 0 0 0 1 1. At the receiver side, 0 1 0. These three are same, whereas the above 0 0 is changed to 1 1, and the 1 as it is, and 0 is as it is, and again the 0 changed to 1, and 0 as it is, 1 as it is, and the 0 changed to 1. This is nothing but the length of the burst error, that is 8 bit, in which to which we are calling as corrupted bits. The corrupted bits are 0 0 is changed to 1 1, and 0 is also changed to 1. Again the last 0 is changed to 1. So this is nothing but the length of bit errors of length 8. Let's see in particular this slide in which we have we have the figure which is the sender and the receiver. The note that length of the burst error, that is 5 bits, is necessarily mean that the errors occur in constituent bits. The length of the burst is measured from the first corrupted bit to the last corrupted bit. Some bits in between may not have been corrupted. So, as we study in the earlier example, where the first bits are changed, that is corrupted, and the last one. Now let us see what is burst error. A burst error is most likely to occur than a single bit error. The duration of noise is normally longer than the duration of one bit, which means that when noise affects data, it affects a set of bits. The number of bits affected depends on the data rate and duration of noise. For example, if we are sending data at 1 kilobit per second, a noise of 11100s can affect the 10 bits. If we are sending data of 1 megabit per second, then the same noise can affect 10,000 bits. The central concept in detecting and correcting error is redundancy. To be able to detect or correct errors, we need to send some extra bits with our data. These redundant bits are added by sender and removed by the receiver. Their presence allows the receiver to detect or correct corrupted bits. We will study concept of redundancy and error detection method in next session. Thank you.